Today we're going to talk about segment lengths and circles, and this is a topic I think that you're really going to like because as I've printed right here, if you can multiply and divide, then this section should be really easy. Seriously, that's basically all you're going to be doing in this section. So I think it's going to go really, really well for you. We're just using some formulas here. Our first theorem, theorem 10.15, if two chords intersect in the interior of a circle, then the product of the lengths of the two segments of one chord is equal to the product of the lengths of the two segments of the other chord. So here you have two chords intersecting at point C. So that means AC times CB is equal to DC times CE, and that's the formula that I've written right here. Okay, so now let's try to apply it. Let's go to the next page. So let's say you have this situation. We've got two chords intersecting at point C. We want to find the measure of DC. Well, we know our formula is AC times CB equals DC times CE. So let's go ahead and just substitute our numbers in. The length of AC is 6, CB is 8. We don't know what DC is, so let's just call it X. So that's equal to X times, I'll use a dot for times, CE. And CE is 12. Well, 6 times 8 is 48. X times 12 is 12x. Solve it by dividing each side by 12, and you get that X is 4. So the measure of DC is 4. All right, so let's move on to the next theorem. If two secants share the same endpoint outside a circle, then the product of one secant and its external segment is equal to the product of the other secant and its external segment. And here is the formula for that. So you can see we have these secants that share this endpoint outside of the circle. The endpoint is F, and FG is the external one external segment, and FJ is the other. So basically FG times FH is equal to FJ times FK. So we're going to be using that formula. So let's say that we want to find JK here. Well, according to our formula, we have that FG times FH is equal to FJ times FK. All right, so let's start off with that and then see what we can do about finding JK. So if we can find the length of FK, we can certainly find the length of JK, because we would just take 3 less than FK, because from F to J, it's 3. So let's go ahead and let's just plug in our numbers here. We have FG is 4, FH is 4 plus 9, which is 13, FJ is 3, and we don't know what FK is, so let's just call it X. Well, 4 times 13 gives us 52, so 52 is equal to 3x. Divide everything by 3, and we get that x is equal to 52 divided by 3 gives you 17 and a third, or 17.3 repeating. Okay, so this entire segment from F to K is 17 and a third. Well, we already know that from F to J, it's 3. So if we took 17 and a third minus the distance from F to J of 3, we would get the length of JK. Well, 17 and a third minus 3 gives us 14 and a third. Okay, so let's move on to our next theorem, theorem 10.17. If a secant and a tangent share an endpoint outside a circle, so here's your secant is ON, your tangent is OL. Then the product of the length of the secant and its external segment, which is here in red, the external segment's in red, is equal to the square of the length of the tangent segment. So in other words, OM times ON is equal to OL squared. Now, what we're going to do is see how this formula works. So you're given this scenario, and you're asked to find ON and MN. So let's use our formula first of all. We know that OM times ON is equal to OL squared. We know that from the previous screen. Well, from O to M, it's 9. We don't know what it is from O to N, so let's call that X. So we have 9 times X. OL is 12. So we end up with 9x is equal to 12 squared. Well, 12 squared is 144. So now we're going to solve by dividing each side by 9. We end up with x is 16. So from O to N, which is x, it's 16. Well, if it's 16 from O to N, this whole thing here is 16, and we know it's 9 units from O to M, how would we find the distance from M to N? Because that's what else we were asked to find. Well, from M to N, it would be the difference between 16, the long segment, and the shorter segment that makes it up. So 16 minus 9. So therefore, MN would be 7. Thank you very much for joining me today. Just keep in mind what we're doing basically is plugging numbers into formulas here. So it's just a matter of recognizing which one we're going to be using. Thank you very much for joining me.